Since Hiroshima and Nagasaki, men everywhere have feared that nuclear weapons might be unleashed in all-out war. Whether they will or not is a question history must answer. But what are the chances of a nuclear weapon being unleashed not in war, not in the interests of victory, but inadvertently? The need to deter aggression has made it mandatory that we keep our nuclear weapon systems ready for action at all times. In meeting this grave necessity, the Air Force today is standing ready with nuclear weapon systems on runway alert and even on airborne alert. In some few instances, aircraft with nuclear weapons aboard have crashed, but none of these accidents has ever resulted in a nuclear detonation. Fire or impact could possibly cause a scattering of unfissioned nuclear material in the immediate crash area. But this would be a concern only if taken internally, as by breathing. In the event of a crash involving nuclear weapons, specially trained Air Force teams are immediately available to identify the problem and quickly decontaminate the crash area. But the basic question remains. A nuclear weapon is involved in a crash, subjected to impact and fire, and there is no nuclear explosion. Why? The answer requires some knowledge of how nuclear weapons work. A nuclear bomb, for example, may consist of a quantity of fissionable material, surrounded by a layer of conventional explosive material such as TNT, with evenly spaced detonators on the periphery of the outer layer. For the desired nuclear explosion to take place, the detonators must all be fired simultaneously. This detonates the conventional explosive, producing a powerful inward pressure wave which is equally distributed over the entire surface of the inner sphere. This force, known as an implosion, squeezes the fissionable material into a smaller and thus denser mass, which then becomes critical and explodes instantly. If a detonator is activated through impact or fire, or if the conventional explosive ignites at any point on the sphere, the explosive will burn without causing a nuclear detonation. If the explosive should detonate at the burning point, it would create an unevenly distributed force that could crack or break up the fissionable material. Safety features are designed into the electrical circuitry to ensure that no current will reach the detonators accidentally. These safety features take many forms. Batteries provide the current for detonation, but this current is not available for accidental detonation because the batteries are designed to remain inert until the weapon is properly actuated. Various other devices control the flow of current to the detonators. An armed safe switch, similar to a safety latch on a rifle, is always in the safe position during storage and handling to prevent the flow of current. When the switch is closed, the weapon can be armed. When open, it cannot be armed. Thermal fuses are another protection against fire. Heat melts the fuse, which opens to disconnect the circuit. Other switches are always disconnected unless, as part of the launch process, they are intentionally closed by launch signals from missile controllers or aircraft crew members. Environmental sensors are impressive little devices that work only if they sense the proper conditions for an actual weapon drop or missile launch. If they don't sense the right speed or acceleration, These switches will remain open and prevent a nuclear detonation even if every other switch in the system is activated. Normal ground handling and transportation does not provide the environment to activate these switches. The safety of nuclear weapons never depends on a single device. A combination is always used. In addition to electrical safing devices, there are a large number of mechanical safing devices, such as lock pins and safety wires with seals. These devices are designed to prevent accidental arming or launching of nuclear weapons. The safety features in themselves are almost foolproof, but the human element demands that they be supplemented by elaborate procedural safeguards. The Directorate of Nuclear Safety at Kirtland Air Force Base in New Mexico is the air staff agency that monitors the Air Force Nuclear Safety Program to ensure that Department of Defense nuclear weapons safety standards are achieved. This specialized organization conducts detailed safety analyses and surveys of nuclear weapon systems, beginning with the AEC system design phase and extending throughout the operational life of the system. One preoccupation influences the entire program of the Directorate. Identify and correct any condition that could degrade nuclear safety anywhere in the Air Force, anywhere in the world. The Directorate of Nuclear Safety also works closely with the Nuclear Weapons System Safety Group, a committee of experts from every command charged with nuclear operations. The group consists of representatives from Air Force commands that work with nuclear weapons, the Department of Defense agencies, the Atomic Energy Commission, contractors, and technical advisors for each field of interest represented. Initial safety studies are conducted early in the planning stage to see that each nuclear weapon system gets off to a good start with the necessary safety features built in. Shortly before the weapon system is scheduled for introduction into the Air Force, the group conducts a pre-operational safety study. During the course of this study, specific procedural safeguards, known as safety rules, are developed and later processed for approval by the Secretary of Defense or his deputy. Another important objective at this time is to make sure that the system and procedures as planned in the earlier stages meet Department of Defense nuclear weapons system safety standards. The group continues its close supervision as long as the system remains operational, constantly looking for new ways to improve nuclear safety. But nuclear safety is not all procedures, design, rules, and surveys. These are important, of course, but ultimately it is people who make the Air Force nuclear safety program work. In a typical Air Force wing, for example, it starts with the commander himself, the man who runs the wing. He's primarily interested in operations, but he emphasizes safety because he knows that it improves his operational effectiveness. The man who helps him achieve nuclear safety is his nuclear safety officer, an expert who spends his time looking for potential trouble and finding ways to prevent it. Equally important roles are played by the technicians and their immediate supervisors who work with nuclear weapon systems. Their professional reliability is under continuous evaluation. Their jobs demand unremitting attention to detail. Every vital step of their work is outlined in technical manuals and checklists which they must follow rigidly. Before qualifying for nuclear safety duty, each of these men has had painstaking professional training, and each has survived background investigations and batteries of psychological tests. After assignment to nuclear duty, their technical proficiency and their mental and emotional reliability are under continuous evaluation. Supervisors at all levels are on the lookout for questionable behavior. If an individual's reliability appears unsatisfactory, he is immediately removed from duty and given a thorough physical and psychological checkup. If the medical examination reveals any indication of mental or emotional instability, the individual is disqualified for nuclear duty and transferred to some less critical occupation. Although the Air Force cannot predict or guarantee absolute individual reliability, it can and has achieved group reliability by a continuing and careful evaluation of all its men who work with or have access to nuclear weapons. This human reliability program is one of the most critical control factors in the nuclear safety program. Another safeguard against the human element is the two-man concept. This rule requires that during any operation involving nuclear weapons, there must be at least two authorized persons present. Each must be familiar with safety and security requirements. Each must be able to detect any wrong procedures that the other may start to use. The two-man rule applies at every level of operations, assuring that no individual is ever in a position to arm, launch, or detonate a nuclear weapon. In the command and control of strategic aircraft and missiles, elaborate precautions are taken to prevent any action that might lead to an unauthorized nuclear launch. During aircraft alert training, for example, the alert order comes into each unit by coded message.
Red Dog, this is Swordfish. Prepare to copy an exercise message. Break, break.
Are to man their battle stations and fire up the engines, but to take no further action until directed by the command post. Proper authentication of the alert order requires that it be decoded by both controllers individually and the results compared. If the message is authentic, the aircraft commanders are instructed to proceed with the alert.
This is a COCO alert. Runway 31.
Present runway winds 300 degrees at 9 knots. Present temperature 67 degrees. Stand by for roll call later.
A COCO alert is a training operation which involves taxiing only. The aircraft do not take off. To protect its aircraft from surprise attack, the Air Force maintains part of its bomber fleet airborne at all times, prepared to proceed to specific targets. Each aircraft has a positive control point beyond which it will not pass unless it receives an authenticated coded message from command headquarters telling it to proceed to target. The aircraft would proceed on direct verbal order only. Despite recent fiction to the contrary, failure to receive such an order would not cause the aircraft to continue on to target. If the message is not received before it reaches the control point, the bomber is promptly returned to its base. Nobody can order aircraft to go beyond the control point to carry out a nuclear attack unless the order is authorized by the President of the United States. The details of how this would be accomplished are classified top secret. In general, however, the order would reach the aircraft from command headquarters. Like all such orders, it would not be obeyed unless authenticated by more than one person, each using a code that is changed frequently for security reasons. When the results are checked and added up, the message is either verified or proven false. These controls prevent the acceptance of a false go order and would stop any crew member from deceiving the others into thinking that a false order is authentic. If a pilot were to attempt to go it alone without orders, he would be unable to do so, because each of the crew members must take individual action before nuclear weapons can be launched. Similar controls apply to tactical aircraft, air defense aircraft, and missiles. Missiles, however, require even more rigid controls because of the obvious fact that once launched, they cannot be recalled. Control of Minuteman missile systems is typical. As with aircraft, the order to launch must be properly decoded and authenticated in each of the several control centers of a missile wing. Prior to launch, both controllers must operate several switches, each necessary for enabling a missile to be launched. This preliminary activity is revealed on the control panels of the other control centers as an intention to launch. If any of the control centers sees the launch commanded or launch in process light go on and has not received a coded, authenticated order itself, it can and will prevent a launch by any one of the others simply by activating a launch inhibit switch. As far as the launch itself is concerned, both controllers must perform simultaneous actions before the final launch sequence can be completed. Physical separation makes it impossible for one person to actuate the system. At the Launch Control Center, tight security measures prevent unauthorized access to the missile complex. No one can enter the area unless he has the proper credentials and is accompanied by at least one other authorized person. Like the other military services, the United States Air Force is continuing its all-out effort to keep our nuclear weapon systems safe through design features, safety studies and surveys, continuing engineering analyses, a human reliability program, rigid safety rules and procedures, and tight physical security. An around-the-clock, around-the-world assurance that our nuclear weapon systems are ready for war, safe for peace.